Good afternoon, everyone. Welcome to the ITS weekly seminar. Our original scheduled speaker, Professor Carolina Onsaro, unfortunately could not make it due to health reasons. So we have switch of speaker and topic, and we want to thank our own Fraser Shilling, and who step up and on such a short notice and give us the seminar today. Fraser is the director of the Road Ecology Center at UC Davis and a longtime affiliate and member with ITS. Fraser, without much ado, I'll let you take the floor.
All right, thank you, Michael. So I, as ITS staff have pointed out, I only have one little screen. So if there's anybody has questions as I go along, please unmute and just ask, or you can wait until the end. I'm fine either way. And as Michael said, I'm with the Road Ecology Center at UC Davis, and the Road Ecology Center is affiliated with ITS. You can find out more about our work at roadecology.ucdavis.edu. And today I'm going to talk about the various silver linings, the impacts of the pandemic on traffic. And you can see one of the ways that we think about and look at the pandemic in the background, showing the widespread and varied distribution of effects of the pandemic, which we're all familiar with now. Okay. I'd like to acknowledge that the presentation is not intended to take away from any of the pain, discomfort, and loss that people have suffered throughout the world and in the US. And I want to acknowledge all of the things that people do in healthcare for us related to the pandemic, including my own wife who's in healthcare. I want to thank medical colleagues and colleagues at the California Department of Public Health for some of their help with some of the things I'll talk about today. Special thanks to Dr. David Wachin, who's an analyst and programmer, works for me. And thanks to several students who supported by NCST and helped with this work as well. These are undergraduate students who helped with the work. This work has been partially supported by different funding sources. The majority of the work was not funded, and it was done basically because we could, as a kind of a fun project. And finally, I want to acknowledge George Floyd and all the other Black and brown men who've been unfairly treated by police and continue to be every day. So as we know, the pandemic had a lot of different effects throughout the world. I'm going to focus on the United States, and this is just showing a range of charts of the first parts of the pandemic, when we were pretty deep into infections and cases and deaths, and we thought things were going really badly at that point, and we didn't know how bad it could get. But as you can see from these charts from different states, there was a pretty wide variation both in the number of cases per day, which is on the y-axis, and the change in the number of cases. And so in this month that's being shown, which is basically late May, some states were going up, other states were coming down, like Connecticut and DC, District of Columbia, and some were staying relatively flat. And a lot of this had to do with how the different states were managing the exposure to the coronavirus in public spaces. And one of the main tools that the states had and other local jurisdictions had was to order people or advise people to stay home. So the chart here shows the different start dates for statewide orders for stay at home across the US. The earliest was in March 15th. Ours in California, I think, was around 3/20, March 20th, but the Bay region had already started a regional stay-at-home order. And the latest one was in early April. So towards the end of March, most states had instituted a stay-at-home order. And the consequence of this, as we know, for travel was both a reduction in overall travel and disproportionate reductions in different modes. So air travel and transit, enclosed spaces with people you didn't know, basically a lot of that shut down to a large degree. And there were a lot of outcomes of this. Some of them were maybe negative economic outcomes. There were probably a lot of positive health outcomes in terms of the coronavirus being propagated. And actually, research on zoonotic disease or diseases of animal origin, which coronavirus COVID-19 is probably one, shows that the more elaborate transportation systems you have and the more efficient the transportation is, the faster these kinds of viruses can spread and get way beyond the public health abilities in almost every country to detect and control these. So we take advantage of and enjoy very efficient transportation systems, but the viruses do too. And so the stay-at-home order was a very effective method at slowing down the coronavirus, but it obviously didn't make very many people happy. So I'm going to focus on some of the things that came out of the shutdown of traffic that we can think of as good, or silver linings, which is an expression in the English language, meaning there's a benefit to something that otherwise might seem harmful. So one of those was, and I'll talk about each of these, reduced traffic leading to reduced crashes, reduced traffic leading to improved air quality and climate change. And I'm going to focus on the climate change gases. And then finally, reduced traffic and reduced impacts on wildlife from collisions with traffic. So there was these different kinds of benefits that we saw. I'm going to refer to a vehicle miles traveled data set quite often and use that as a quantification of travel in the US. And these data come from streetlightdata.com. They have made pretty much immediately during the reduction in travel and in the beginning of the pandemic, they started making their data sets available for free online. Now I think they're still free for non-commercial entities, and you just have to sign a data sharing agreement. And they measured county scale vehicle miles traveled throughout the US. And so for each county, there was a daily estimate of vehicle miles traveled. And this came from the movement of cell phones and then using algorithms to sort out, was that movement related to pedestrian travel or some other kinds of travel or driving travel? And they came up with an estimate for each county for the vehicle miles traveled. And so you can see right here, if you look at the dates on this chart here, this is March 1st at the beginning over here, and this is the end of February 2021. So the travel went from around 8 to 9 billion miles traveled per day. It dropped off about 50% throughout the US to about 4 billion miles traveled per day. And so this is about a 50% reduction. And as we know, now we're later in the pandemic, we saw a return over time throughout the US, and this varied quite a bit among states. Some states had fairly rapid return. By May, in some states, traffic was almost back to normal, quote unquote. In California, traffic actually stayed a little lower. It remained about 10 or 20% lower than normal, even now. And so there was a lot of variation, but overall in the US, traffic mostly returned to pre-pandemic levels by summer, by midsummer. There was a seasonal reduction in travel through winter. This usually happens. However, you'll see in a later chart that this drop from around 8 or 9 billion back down to 6 is about twice the size of the drop that we would normally see. And this may be due to continuing surges in the pandemic. And you can see this in the graph at the bottom right, where we had this winter surge in cases per day on the y-axis. And so this is December 2020 at the bottom of the x-axis there on the right. And this corresponds roughly with when we saw a larger reduction than usual for wintertime travel in the US. And this reduction in travel varied throughout the country. So as I pointed out, and this shows it spatially. So a lot of Northeast states had bigger reductions in travel than other states throughout the country, including larger than California. In California and other states, there was some effects on speed. There were news stories, California Highway Patrol saying that there was more speeding, very, very high levels of speeding. And when we looked at the Caltrans sensors on PEMS, we did see occasionally that there were those really excessive speeds. But if you look at the column here, this is looking at multiple highways in California and looking at the peak speed change between before the stay-at-home order and after. And the peak speed, the 95th or 99th percentile miles per hour, only changed by a few miles per hour for these different highways. The average speed also changed, but only by a few miles per hour. So it seemed like there was an increase in speed, but one thing that might be happening is that it's the California Highway Patrol is having an easier time catching the people speeding or an easier time seeing the people speeding. And so we don't necessarily know which it is, but we certainly know that there was some increase in speed. In terms of crashes, which are quite related to speed, there was actually a decrease in crashes of all kinds. And I'll walk you through these charts here. So the top chart starts January 1st, 2020, and it goes to February 28th, 2021. And so I'll just highlight this area right here. This is right when the statewide and the Bay orders started. And the red area, these are all traffic collisions, and the green area is a subset that are injury, primarily injury crashes. There are a few fatal crashes as well. So traffic crashes of all kinds declined 50% within the first 2 weeks of the pandemic, and then went up to about 80% of normal through the summer. And this was paralleling the changes in traffic volumes as well, which only went up to about 80 or 90% of normal in the summer. There were a couple of events right here in, and these were in Southern California. There were major, and Central California, there were major rain events. And this led to a sudden spike in crashes, including injury crashes. But otherwise, the numbers of crashes stayed very low through into the midsummer. Fatality crashes did not change, and in terms of absolute number. And what that means is since we had a reduction in the number of vehicles and vehicle miles traveled, that means there was actually an increase in the rate of fatality crashes per vehicle mile traveled or per vehicle. So this is that's something that's probably worth looking at. And actually major injuries also have the same thing. And that's consistent with the idea that you can see in this previous graph. If we look at this chart, this is 405 showing the speed on 405 in Southern California. And normally the speed would go down during the afternoon. This is the period shown here, and this is due to rush hour traffic. Everybody slows down. But during mid-April on 405, traffic speeds stayed fairly constantly high. And so that's consistent with the idea that you would still have more fatal and major injury crashes, which tend to occur with high-speed crashes. A lot of this information comes from a system of ours called CHIPS, which is a real-time querying of traffic crash information throughout the state. It's the only one of its kind, and it's very spatially accurate. And so if anybody is interested in traffic safety, feel free to contact me about using these data. The reduction in crashes that we saw in injury crashes was confirmed independently with Sacramento Regional Hospitals reporting declines in vehicle accidents and also injuries to pedestrians and cyclists during the same period of before the stay-at-home orders into April. And that's not a change that we would normally see in, say, 2019. There was no change at all. The crashes were distributed fairly evenly throughout the state in terms of reduction. And so on the left, you can see the pre-pandemic condition map. This is density of crashes throughout the state. And on the right is density of crashes in April, mid-April. And you can see basically the red colors dimmed, the orange colors dimmed, all the colors got slightly less intense, indicating there's fewer crashes, but the distribution of those is fairly even throughout the state. So no single region benefited from this reduction. Costs, these are estimated costs using Federal Highway Administration coefficients for how much different kinds of costs, how much different crashes cost. And we looked at pre and post order, stay-at-home order costs. And basically, California saved about $40 million per day in crash-related costs from before to after the order. And so if you were to look at that over, say, a month, 30 days, then that's $1.2 billion saved from reduction in crashes. The next thing I'm going to talk about is greenhouse gas emission reductions. As opposed to the previous section on traffic safety, this is more based on estimates, calculations of estimated greenhouse gas emission reductions. So the previous section was, we call it real data, and this is more estimates. So just keep that in mind. And I looked at several different aspects of this. One is, how did estimated fuel use change? How did that look in terms of carbon dioxide equivalents for fuel combustion? And then what kind of changes might that result in terms of fuel taxes? And fuel tax revenue is really important to most states, as we know, because it's the source of a lot of transportation funding. And for those states that are working on improving transportation and making it more sustainable in terms of greenhouse gas emissions, a reduction in fuel tax revenue might actually reduce the state's ability to make those kinds of changes. So there's these kind of opposite effects. As you reduce fuel use, you're actually improving the greenhouse gas emission situation. But because it also results in a reduction in fuel tax revenue, you might affect the ability of states to implement climate change policy. So this is the same, same kind of map I showed before. So because VMT reduction has a parallel proportional decrease in estimated greenhouse gas emissions, the map looks essentially the same. And what you can see is this variation among states, as I said before. There's also a variation over time, and I'm showing an example here from California. So this is a little different chart than I showed before. The beginning of the x-axis here is January 1st, 2019. And so we can think of this as a typical year of vehicle miles traveled, where there's lower travel in the winter and spring, and it increases during the summer. A lot of that is tourist or recreational travel, and it goes back down again into the winter. So you can see a similar shape for 2020, but the whole curve is lower. And what I mean by that is, if you take the average here of about 1.25 billion miles traveled per day in California, there's about a 25% reduction between summer of 2019 and summer of 2020. So, and this is true for winter, spring, and all the other comparisons you could make. So there's a reduction from normal. So even though we did have an increase in traffic coming out of the early days of the pandemic up into the summer, the increase led us to a new normal, which was slightly lower than previous years. So this shows oops, sorry, I gotta change something here. Can't see my own results because the screen share bar is in the way. I'm going to just pause here for a second and answer a couple of questions that showed up in the chat bar, which I just noticed. There's one question: could we account for the lower emissions curve for 2021 for California, with traffic coming back to 80%, to improved fuel efficiency and higher EV sales? And so basically, would that 20-25% reduction in estimated greenhouse gas come from improved fuel efficiency and EV sales? And I don't think so. Others on the listening to the seminar may study this, but the information I've seen, that would be a very rapid turnaround. I don't think we've had that rate of increase in fuel efficiency or EV sales that could lead to that degree of change. So I would say that's entirely due to a continuing pandemic response. Okay, so estimated greenhouse gas reductions basically took all of the travel in VMTs, converted that to an equivalent fuel use based on average fuel consumption for the fleet of autos in the US. And you can see the table, the raw values along the bottom here. Basically, because VMT decreased by 50%, therefore estimated carbon dioxide equivalents decreased by 50% from pre-pandemic to post stay-at-home orders. And you can see the percent reductions. These are 8 weeks. So approximately this green area here, an estimate there is about 1 to 2% of annual greenhouse gases in the US were reduced during that period of the pandemic. And so that's a very high rate. So if we were to do a 1 to 2% reduction in greenhouse gas emissions regularly every year, then that would be about half of what we need to do in order to meet our Paris Climate Accord goals. And then the second period here I highlighted in green, this is indicating that there may be a second response in terms of reduced traffic because of the surge that occurred in late fall into winter. And so I think that that's real. I haven't investigated well enough to say for sure, but I think there's been a second reduction in traffic that took place during that surge, which would also help us to meet those Paris Climate Accord goals. So if we had about a 4 to 5% reduction in greenhouse gas emissions per year, it would help us meet our California and also US goals for greenhouse gas emissions. And with just a couple of months of traffic reduction due to the pandemic, we got halfway to meeting those goals in that 1-2 month period. In terms of fuel use and revenue, so taking the same estimated approach of taking vehicle miles traveled and giving it an equivalent fuel use, we can see that there was a reduction in estimated fuel use from almost 3 billion gallons per day per week in March to 1.5 billion gallons per week in April. This actually resulted in a big savings to drivers. They spent about $5 billion per week less in purchasing fuels. But there was a knock-on effect because if you buy less fuel, you're paying less fuel tax, and the fuel tax is collected by state and local governments. And so there was approximately $500 million a week loss in fuel tax revenue in the US. And in California, we have both think of it as the regular or normal tax, and then we have the SB1 fuel tax supplement. And there was a loss of $1 or $2 billion in the SB1 fuel tax supplement from this decrease in fuel purchases in California. And that could have an effect on subsequent activities or planned activities under SB1, because those activities are based on continuing revenue streams. And this is the last thing I'm going to talk about, is impacts to wildlife. This is actually one of the primary things that we study at the Road Ecology Center, maybe not surprisingly. And I'm going to use the same kind of model or approach that I used for the previous ones, and that is to look at the before and after the stay-at-home orders as an indication of the pandemic effect, while recognizing that some of that effect has continued on even until the beginning of this year. So wildlife vehicle collisions are usually among the top 3 threats to wildlife in most of the world. And what that means is that if you look at what causes excess wildlife death or human-caused wildlife death throughout the world and impacts to wildlife populations, traffic collisions or vehicle collisions with wildlife are usually among the top 3. So in California, all of the top 3 or 2 of the top 3 impacts to wildlife from human activities are related to roads. One of those is fragmentation, meaning that if you think of wildlife as living in a rectangle and you put roads cross-hatched across it, then those roads will break up that area, that habitat area, into small pieces or fragment it into small pieces, which will affect wildlife populations and wildlife species in a negative way and can eventually lead to their extinction. So that's the effect of the roads by themselves. Once you put traffic on top of those roads, not only are those roads fragmenting the wildlife and separating them into small groups, but individual wildlife are also dying, and in some places at a high enough rate that you can have local extinction of certain species, meaning that they just go away completely because of collisions by vehicles. So this familiar chart now on the top left, you can see the traffic changes in California since January 2019. And we compared the rate of wildlife vehicle collisions in California and 3 other states in the US between the period late February to early March and mid-April. So basically before and after the stay-at-home orders in each of the 4 states. And we called this, these 2 periods, which I haven't referred to before, period 1, which would be the think of that as the pre-pandemic or pre-stay-at-home order period, and period 2, which is the post-stay-at-home order period. So in the top right here, this shows the 4 states, California, Idaho, Maine, and Washington that we looked at. And I put a red box around an important piece of data. Both of these tables are from a publication, which is the citations at the bottom of the screen. And it's, I think it's open access if anybody wants to access it. And you'll see a lot of the names here, the same ones that I acknowledged. These are all undergraduate students, and it's their first publication. So I was happy that we could do that. And thanks to NCST for their support for that. So across state highways, this is a slightly different way of looking at traffic. So we looked at both vehicle miles traveled, and for these 4 states, there was also state highway information. Some of it was estimates and some of it was real measures. And so in California, for example, we looked at 20 different state highways and interstates for what the reduction in travel was along those in terms of traffic volume. And so you can see the percent change in traffic due to the stay-at-home order for these 4 states. The average was about 1/3 or 30% reduction in highway travel. It's a little bit less than the estimated reduction from vehicle miles traveled. And it's not clear why exactly that would be the case, except that you might expect there to be continuing use of state highways and interstates for freight travel, whereas you might expect there to be a reduction in local travel by people who aren't moving freight in response to the pandemic. So the table 2 here at the bottom, this is our primary data set. This represents tens of thousands of observed animals found dead on roads over a 6-year period. And 2020 is our year of interest. So the way this table works is that the rows correspond to different years. And then going across the top, each state, California, Idaho, Maine, and Washington, we looked at the daily rate of collisions reported to emergency. So these are state reported collisions with large wildlife. The daily rate between before the stay-at-home order, period 1, to after the stay-at-home order. And for every state, there was a statistically significant decrease in the daily rate of wildlife vehicle collisions reported to emergency personnel from before to after the stay-at-home order. So just as traffic was reducing by about 50%, the rate of collisions with large wildlife decreased by about 1/3 across the 4 states. When we looked at previous years, there was never an occasion in any of these states where the rate of wildlife vehicle collision went down from period 1 to period 2. And the only statistically significant change that ever occurred is that it would go up. So normally in California, we would have no change or an increase in the rate of wildlife vehicle collisions on highways from period 1 to period 2. And what we found is there was a decrease, and suggesting that the phenomenon we were seeing across these 4 states was a real reaction to the reduction in traffic. And this is consistent with the literature, which is shown previously that when you have a change in traffic, when you have higher traffic highways versus lower traffic highways, you can see a difference in the rate of wildlife vehicle collisions. What we have here is something entirely different. There has never been an experiment like this where traffic volumes were reduced by half and then to study the effects of wildlife. So this was an unintentional but excellent experiment in traffic reduction and impacts on nature. So in the United States, we have about 1 million wild animals per day of any size killed on roads and highways. About 1/3 of those are birds, and the remainder are reptiles, amphibians, so lizards, snakes, frogs, turtles, and then various sized mammals, from the smallest rodents and chipmunks, mice and chipmunks and so forth, up to the very large bear elk, moose, and so forth. So about 1 million per day, wild animals of all sizes die on roads and highways in the United States. So 1/3 reduction in this rate of mortality could mean that over the course of the traffic reduction during the pandemic, tens of millions of animals that would have died didn't die. So it was a net saving in terms of wild animals dying on roads. And if we look at the history of protection of wildlife in the United States, this is possibly the largest conservation action that has ever been taken in the United States since we created the national park system. So we have, since we created the national parks, which had a lot of benefits for wildlife, we've never intentionally or unintentionally done anything as significant as this traffic reduction to benefit wildlife. So conclusion, so I'm just going to sum up all of the things I've already talked about. After the shelter-in-place orders, there were the following kinds of positive impacts. The first is that total travel in the US dropped about 50% after the stay-at-home order. There was variation among the states and among counties, and I think that that variation could be quite interesting. One thing I didn't mention that we looked at is that the states that had the greatest reduction in travel also had the fastest response in reduced coronavirus propagation. And that's what you'd expect. If you have fewer people driving shorter distances and not being exposed, you would expect the pandemic to slow down. In states that returned to normal levels of travel very quickly into the summer, they were the states that we saw in the summer have the fastest surges in coronavirus. So there's definitely a very interesting disease transportation connection there. There's also, for those of you who are political people, there seemed to be some relationship between how much traffic changed and who the state voted for or the county voted for in the 2016 election. So that's probably not surprising, but it was something else that was interesting to look at. In California, where we have the best data to look at crashes, it's real-time data, we saw about a 50% reduction in crashes of all kinds per week, except during an exceptional rain event in 2020. And then there were actually a couple more in the winter of 2020 to 2021. The costs associated with crashes declined about $40 million a day. And so there was if we looked at a 2-month period, there was about a $2 billion savings to society from these reduced crashes. Estimated greenhouse gas emissions also declined, as you might expect, and it put the US on track to meet Paris Climate Accord goals. However, that statement is based on the idea that we might either repeat this kind of behavior or we might use the behavior in a learning fashion and say, if we want to meet the Paris Climate Accord goals, we either have to drive less or use less fuel and maybe more electrification in order to meet those goals. Fuel tax revenues in the US declined about $500 million a week during the 8 weeks after the order. And that's going to have knock-on effects for transportation implementation. I'm sorry, I just noticed I've got this GHG is hanging out there. It's going to have knock-on effects for building transportation projects, which actually would be a positive thing. If we have reduced fuel tax revenues, we might build fewer roads and highways, which is a net benefit for nature. And you don't often hear that in an ITS seminar, but building less roads and highways is beneficial to nature. That being said, if we had policies that reversed some of the negative impacts of transportation by either reducing the road system or reducing the greenhouse gas emissions, then we would want to fund those from fuel tax revenue. And so this would have a potential effect on that. So in California, reduced SB1 fuel tax revenue could have had a knock-on effect on the ability of the state to implement some of its transportation-related climate policies. And finally, impacts to wildlife declined about 1/3 in 4 US states between March and April. And that effect, no doubt, continued on through the, sorry, I was just looking at one of the questions that just came in, through the reduction in traffic. So we're going to look at this again now that a year has gone by to see what kind of net effect there was over the entire traffic reduction period in California, because California did actually have an overall reduction in travel. And that's it. Thank you very much for your attention. I'm going to go ahead and answer this one question before moving on to all the rest of the questions. So a question from Lindell Price: what is included in the costs associated with crashes? So the way that the Federal Highway Administration and to some degree NHTSA calculate these costs are, there's the very localized costs of the vehicle damage, potential injury to the person driving or passengers. And then there's these other external costs. There's insurance costs, there's emergency response costs, potential traffic delay costs, and all of those go into average cost per incident for different incident types. And they're very broad categories. So property damage only crash might cost, say, $15,000 on average, but you might have a very small accident that only costs a few $100s, or you might total your Tesla and it sets you back $100,000. So, there's a very wide range, but we used the average cost per incident type and corresponded that to the incident, the traffic incident types that we record. And that's how we did the crash cost estimate. So thank you for those questions. Thank you for your time and your attentiveness, and I'm happy to take any more questions.
Thank you, Fraser. And I would like to remind our audience that for students, you can use the raise your hand feature from Zoom to ask your questions. And for our other audience, you can use the Q&A feature to ask questions. And since this is also a class for our students, so we'll go over the questions from the student first. And then I think today we have ample time to probably answer all the questions. So if you have a question, you can use the raise hand function from Zoom.
We have a couple of questions in the chat. Do you want me to deal with those first?
I noticed Ray had her hand up.
Okay.
Yeah.
Go ahead, Ray.
Hayden, so Hayden, can you ask your question?
Sure. Yeah, I was just wondering if you saw any relationship between income and driving behavior changes.
Yeah, that was actually the way we were starting to look at that, was the relationship between income and ethnicity and crashes. And I started working on that with my colleagues at UC Davis Medical Center to see if there were disproportionate benefits, basically, were people working from home who maybe were well off and maybe more white collar like me. Maybe we had fewer crashes because we were able to work from home, but people who were termed essential, meaning they didn't get to work from home, they still had to drive, and maybe they were exposed to more crashes. And we started to look at that, but then my medical colleagues at the medical center were drawn into the surge, and they weren't able to focus on research anymore because they were in the emergency room. So yeah, we weren't able to do that, but that's a really critical question. And I think it's a great policy question because it points out another kind of effect of the pandemic. Not only were people potentially more impacted who in certain ethnicities or income groups from the pandemic, from the coronavirus itself, but then if they were also in work situations where they weren't, that they had to keep driving, they had to keep being exposed, then they had a disproportionate negative effect as well from that. And so there's, I think, a lot of ways you could look at that. But thank you, good question. Ray?
Ray, you're next.
Yeah, thank you. Thank you for a great presentation. It was really interesting. I want to go back to the saving money, and you mentioned that the number of emergency calls for animals have been reduced, or in a third, I think. So do you have an average cost of each call that goes to emergency call? So this third reduction, how much money we saved for that?
Right. Well, the closest we could get to that is because a lot of those actually resulted in some kind of potential effect on the vehicle or the passengers, then there's the same kind of cost you could give to the all crashes, not just the ones related to wildlife. But I didn't do that. Typically in California in previous years, our costs from collisions with wildlife is about 250 to 300 million per year. And so if there's a 1/3 reduction, let's say it's a 1/3 reduction for a couple of months, then it's going to result in, let's say 50, about $15 million reduction in costs of crashes associated with wildlife. That's my top of the head estimate of that benefit. So that's certainly a benefit. It's not as big a benefit as all crashes for any reason. And from a wildlife point of view, I think the primary benefit is just the wildlife didn't get killed, and not just the large ones, which are the only ones that we had data for, but all of the other 95% of the rest of the animals are much smaller and they're not recorded. So all of those animals are going to receive that benefit of not getting killed.
Yeah, my point was that if we could compare or justify, I know it should be justified from another different point of views, but
Yeah.
if we could justify that loss of gas revenues with this amount of savings and so on.
How does the gas revenue, how does that relate to the wildlife part of it?
When you mentioned that the gas revenues have dropped because of the pandemic and less driving, so like money speaking, I was thinking, okay, yeah, we are not earning the money that like the gas revenue, but we are not spending the money.
Right. Yeah.
Things.
Yeah. Okay. Yeah. That totally makes sense. Actually, the savings from reduced crashes, if I'm recalling correctly, was greater than the reduced fuel tax revenue. So if you think of that as two streams of income in society, one is a cost to society, and the other is it's a transfer of funds really within society. But their reduction in crashes saved us more money than we lost in terms of fuel tax revenue. So it was a net benefit from that point of view. But if you work in a transportation agency, you don't necessarily want to see that, right? Because your budget's decreased. And so that was a bit of a sticky point, I think, last summer, where we had a lot of press coverage for some of our reports. Was we were saying, hey, we have these net benefits, and actually drivers are spending less on gas, and that's good for them. But the transportation agencies in the state were suddenly faced with these shortfalls of revenue. And there was a lot of scrambling to really figure out, well, how much is that going to be and what are they going to do about it? I don't know what the outcome was. They don't necessarily share that publicly.
Thank you.
Yeah, you're welcome.
Patricia, you have a similar question about the reduction of fuel revenue. Would you like to ask that?
Yeah, that might have been answered just now. My question was, what do you think is the short-term effects of this reduced income from the fuel tax?
Yeah, I think what probably happened is that there was a lot of negotiation, pretty hard negotiation, because the fuel tax revenue decrease probably was a 10 to 20% reduction in I'm just totally estimating this, in the state's transportation budget. And so whose project gets cut, whose program gets cut, that must have been a huge question mark going into the end of 2020, because that was its current year money, and it's also projecting into the 21-22 budget. So, I'm sure it was a big scramble. I don't know what the outcome was. I don't know what they decided to cut, whether they decided to cut, paving or lane work, or if they decided to cut transit and climate change related work. I have no idea, but that would be definitely a good thing to find out. One of the things that we tried to do related to that, we wanted to basically create an analytical approach that was a rapid response to what was happening in the pandemic. And a rapid response analysis of these policies so that in the future, if we are in a situation like this, we're not waiting for 2 years or something for papers to come out to say what happened. Instead, we can have an immediate analytical response and say, this is what's happening. Here's what's happening right now with fuel tax revenues. What should we do about it? So just shorten the gap between the events occurring and then the analytical and then policy response to those events.
Any other questions from our audience? I have a question. This shelter at home place and the reduction of events, clearly you showed that there's benefits to the environment and reduction of accidents, and also it's increased the welfare for animals. Like people doing fasting, from time to time, and do you suggest we should implement a traffic fasting policy or incentives so people maybe not driving in some days and do traffic fasting either as individual or as a group, and not like dramatically like what happened in the COVID era, but in a year maybe you can practice that for a few days or spread it out. And so if we want to do that, what kind of mechanisms can we sort of have these kind of policies or measures?
Yeah, no, I think that's a great idea. A road diet, a traffic diet is an excellent approach. And actually, we could say, well, this is what we should do. But I think what's actually happened is that a lot of people, certainly in California, have decided this is what we're going to do, or this is what we have been doing. And so the net reduction in traffic that we're still experiencing, about 20% reduction, that's probably a consequence of this changed work behavior in part. And it's also probably a consequence of people gaining a new practice. They shop less frequently, or they change their visiting habits to relatives or recreation and tourism. If we maintained that, we'd suddenly have this huge reduction, 20% reduction in transportation-related greenhouse gas emissions, 20% reduction in crashes, and all of these things that have real costs associated with them would be a massive economic benefit and a benefit to nature. And if we think about, well, what's our behavior like now? And are we okay? Well, the primary stress of the pandemic, I doubt it's primarily driving. I think the primary pandemic stress is, am I going to get coronavirus? And then what's the economic outcomes of all of this? And are we going to make it? So I totally agree with you. I think a traffic fast periodically is or I would call it a traffic diet, is something that we've learned how to do, and we should just keep doing it. And then that combined with electrification and other things will get us on that path to the Paris Climate Accord.
It will be really interesting to see how some of this, the new habits or new norms that we learn from this pandemic, and how long does that last, whether it's stick or will disappear very quickly. And I think there's probably a lot of further study to after the pandemic.
Yeah.
To look into this these various factors.
Yeah. I mean, the expectation, I think, last summer as traffic was increasing again was that, oh, we're just going to go back to normal, whatever that was. And what I think we've demonstrated is that, and maybe it's just a continuing effect of the pandemic. So maybe I'm still being too optimistic, but I think one potential optimism is that reduction in traffic, if we work hard, we can make that stick. And suddenly, we're on the road to the Paris Climate Accord goals. And I also study sea level rise and climate change effects. And if we don't get on the road to the Paris Climate Accord, we're going to have a totally different level of effects. The pandemic will be a learning experience because, all of the things that could come with climate change are going to be pretty severe. So, I really, really hope that happens, the learning process, the silver linings.
Yeah, and also, the way people work and the workplace change and the relocation and a lot of
Yeah.
that have longer term consequences. So yeah, this is it's a natural experiment
Yeah.
that will have a lot of I think interesting things that people can study for a while.
Yeah. Got a couple more hands up.
Oh, okay. So let me look at my screen and I cannot. Okay, maybe next page. Don't see any
Zachary?
hands.
Yeah,
Zachary?
I can speak.
Yeah. Okay. Yeah. Please. Is it okay?
Yeah, I just had a question about. So, I think during the pandemic we've seen a decreased use of public transit and to some degree maybe a decreased trust of it. Do you think that that will have a lasting impact or potential like increase in individual vehicles being used immediately post-pandemic? Yeah, what are your thoughts on that?
Yeah, no, I'd be guessing just like most of us, right? That I suspect there will be a long impact. I don't think it'll be a forever impact. And because, we've had scares before. There was SARS, for example. There were definitely short-term impacts on travel. I can't remember where I was going at the time, South Korea or Vietnam, but there was definitely a lot of concern then, and we thought, oh, it's people will be really worried and they won't. But no one thinks about it anymore. We didn't think about SARS for a long time until COVID-19 came along. So I think a good thing and bad thing about being human, we forget quickly, right? As a group. So I think that we will forget what it was like, and within a couple of years, the same people who might be using transit or want to use transit will go back to using transit. Maybe we'll do it slightly differently. Maybe we'll have hand sanitizer with us. But yeah, I could see it happening. And I think the way that's going to happen, and this is where it's maybe more difficult, is if the funding for transportation continues to be more and more directed towards transit, then and less towards highways, then the incentive is going to be there more and more to go to transit, because roads and highways will be busy, they'll be congested, hopefully. And so it'll push people into transit. I mean, that should be our goal. And then the idea of the transit being safer, I think that it's really difficult to get away from the fact that you're in a confined space that may or may not have good filtering, air conditioning, and you just kind of have to deal with it. All that being said, the people who use transit they maybe fall into that same category of the people who are disproportionately negatively impacted during the pandemic, because their opportunities for travel may be limited to transit versus being able to drive a vehicle. So I think we really need to work on making it inconvenient for everybody, including the well-off white-collar people, to drive vehicles so that we can push everybody into transit, and that'll increase the popularity and support for it.
Any other questions?
Does Trisha have her hand up?
Yeah, I have a quick question. This is again on the fuel tax. Do you think that the drop in revenue from this past year is encouraging people to restructure their revenue streams? Like ideally in the future, they wouldn't be relying on fuel tax.
Yeah, it's definitely the currents go back and forth. So sometimes people say, well, we need a fuel tax revenue because that's a good index of driving activity. And then sometimes there's a pushback saying, well, that in a way it encourages the construction of roads, because then you get more fuel use and therefore more revenue. And so there's a perverse incentive there. I think that the response, the natural response or artificial response, whatever it is, of state transportation agencies to the reduction, because they all rely on fuel tax revenue over the last year, I'm sure they're looking at non-tax revenue streams in order to not have this kind of situation occur again. And it could be that something as simple as a legislative package that says, when this occurs, we'll give you an extra bump from the general fund. I'd be surprised if that happened. And outside of that happening, you've only got limited things left. There's car registration fees, but those are annual and they don't have the frequency. So I'm sure there's a mad scramble, but I wouldn't want to guess as to what the solution is. I mean, there's an obvious solution. You just increase taxes so that you can pay for stuff when you need it. But I must be living in Sweden or something to say that. So I'm not sure that's going to happen here. These are great. I love these speculative questions since I love speculating. So thank you to everybody for those. There's another question here in the chat. Aditya Ramji, have you had a chance to review the new transportation infrastructure bill by the administration, and if it includes anything towards increased road safety and wildlife transportation conflict, or alternatively, would the new infrastructure bill exacerbate any of these issues? Well, the one good thing about the infrastructure bill is that it doesn't have a lot of road and highway funding compared to the size of the bill. I mean, there is a lot of funding in there for conventional transportation, but there's a lot of funding in there for other kinds of infrastructure as well, including schools. So in that way, I think it's a good thing. There was a proposed bipartisan amendment to the bill a couple of years ago. This was when the bill was a previous bill, but the same kind of idea. And it was for $300 million to improve wildlife vehicle conflict across the US. That sounds like a lot, but if you divide it into 50 states, or even if you do it proportional to travel, California would get 30 million in one calculation, or it would get 6 million in another calculation. And there's one wildlife crossing being built in Southern California right now. The estimated cost is $60 million. It'll be the largest in the world, but these crossings, this is a type of activity you could do to reduce this wildlife vehicle conflict. They're expensive, just like anything, like a bridge. So that amount of money, 300 million, is really a drop in the bucket. California alone should be spending, that order of magnitude on reducing wildlife vehicle conflict. But as you'll notice from ITS seminar series and other seminar series, those kinds of impacts to nature, are not a priority of transportation. Even though they are in ecology, transportation is one of the biggest impacts by humans on nature. That's what we study. On the transportation side of things, it is not a priority. It's rarely ever discussed. And I think a lot of that comes down to actually fix that would cost a lot of money. So it's easier to ignore it than to actually address it. So I'd be surprised if the new infrastructure bill did much to improve this situation. Hopefully, I mean, there are other states in the US that do much more than California. They tend to be Republican states, which is always an irony to me. But, I think states, that's really where we're going to find this kind of action, is at the state level.
Somehow, Fraser, you can see the questions, but somehow on my screen, I cannot see any of these chat questions that you mentioned. So it's good that you can see them.
There's no more in the chat, and I'm not sure if there's any in the Q&A. I don't see any in the Q&A. So let's see if there's any other hands up. Do you see any hands up, Michael?
Not from my screen, and let me.
Yeah, I don't see any either.
Oh,
okay.
Yeah. Well, if not, we'll stop it here. I want to thank our speaker, Fraser, again, and see everybody next week.
Thanks, everybody, for your great questions. Thanks, Michael. Thanks, ITS.